Transportation needs innovation to address challenges like congestion and sustainability. At the same time, innovation in the realm of startups can greatly benefit from algorithms developed in the transportation field. This video presents 4 examples of such algorithms. Our agent is EV startup named Starling. Starling starts from early stage and will travel to its destination product market fit in 5 minutes. Starling's first step is time-space diagram. In time axis, early stage startup goes through 15 steps from goal setting to hiring. In space axis, it has 9 business components from partner to customer segments. It is challenging to plan 100 dimension, but time-space diagram can help us build dynamic business canvas. Starling's second step is analyzing environment. Before experiment, Starling analyzes profit, revenue minus cost. Market regulatory investment affects revenue, and technology affects cost. EV startups' revenue is affected by government subsidy policy, market saturation in rural, suburban, urban, investors' interest on EV sector. Also, production cost of 300 or 400 miles can be analyzed with emerging technologies. This 3x3 Markov chain combines 3 markets and 3 products. Starling analyzed rural markets with sparse charging stations, preferred longer range, 400, but urban market that doesn't need such long range preferred cheaper option, 300. Not only customer but also competitors or substitution should be considered for this opportunity analysis. Upon learning government's large fund to construct EV charging in rural areas, Starling decides to make a bet in rural market. Now Starling jumps into action. On top of 9 Markov chain states, Starling defines 4 actions: pivot product, pivot market, scale, fail. It starts experiments with 300 range EV to rural market. Instead of defining full Markov decision process, Starling uses heuristic decision rule. It experiments selling 10 EVs of specific range to target market. It first makes a range of prediction on EV sales based on its belief on the product and market. If real sales is above high bar, it scales. If real sales is between high and low bar, it pivots product. If real sales is lower than low bar, it pivots market. If it runs out of cash, it fails. When pivot product action is chosen, it updates products in the same rural market. When 10 EVs with 350 range, they continue with the second experiment. However, the sales in the rural market with updated product was again so poor that Starling admitted its bet to rural market was misplaced and pivot to suburban market. Starling continues this experiment with 350 suburban, 300 suburban, and finally 300 urban before scale. This is a state transition diagram where state is defined by market and product plus cash. Belief is also a state and will be shown later. For each cash state, we have 9 states as a combination of 3 market and product types. For action, we have pivot product and pivot market action, scale action, and fail action. State of Starling's belief on market acceptance for EV is represented with mean mu and standard deviation sigma. Mu and sigma can each be interpreted as optimism and confidence. Starting with normal distribution with 4 and sigma 1, we can see how market signal from each experiment decreases mu and increases sigma. Considering low bar from Starling's decision rule is mu minus 2 sigma, and it pivot market. When sales is lower than low bar, with higher mu and lower sigma, Starling might have been able to exit rural market after the first experiment. This implies high optimism and confidence can be helpful in quickly folding a mediocre market, which helps finding a product market fit. Starling's fourth algorithm is pivot. Simplex and Startup Pivot has a lot in common. Algorithmically, Simplex moved between corners, and Startup changed business plans, both of them to find the best solution. New feasibility environment. For Simplex, updated constraints change the shape of possible solutions, and Startup, new technology updates what's possible for the startup. For new desirability, Simplex, updated objective function changes the direction of improvement, and Startup, new market, for instance, eco-friendly car demand updates what's desirable for the startup. Assuming we have Startup's time-space diagram, we can translate this into business model network. And 2 by 2 by 2 by 2 combinations of nodes in the graph corresponds to 1 vertices out of 16 in the polyhedron, the network. Given this geometric understanding of polyhedron, it's easier to understand pivoting to new feasibility, as in the second figure, the feasibility space is halved, and this affects the optimal solution change from the first red dot to the second red dot. Whereas in the new desirability, the objective function, the purple arrow direction changes. That results in the change of the red dots. Starling's next step is to explain strategic pivot, meaning how agent chooses the environment.